So here we are, most of the way through a strip down of a Mark III 1.8 engine. This is my friend's original engine from his car. He was getting the old dreaded oil usage. There wasn't any knocking, but he was getting loads of oil usage last year. He went for the option where he bought another known 1.8 engine, swapped it in, and it's doing the same thing. So it's a 1.8 thing or an early engine thing. So basically we thought, rather than just get another third unknown engine, we're going to take this one apart, see if we can do anything with it, and go from there. So this is I've been told 120,000 mile engine. So straight away you're thinking, right, it probably needs reboring, that type of thing. Well, that's kind of what we're going to look at. So this isn't a video about how to do everything, because I'm not an expert in these engines. I don't want to do a how-to video, just going to show you the process, or not the process of, but basically what we're up to, see what we do, end result, and hopefully you know, show you what can be done. So got the head off, got all the ancillaries off, had a look at the bores. In my limited knowledge, what you're looking for straight away is any scratching. If you've got scratching, real, you know, deep scratches, whatever, it's always going to leak, and you're going to really need to be bored. These, on every single one, when we've turned it over, as far as I can see, there is no horizontal scratches. I can't see much hone marking left, so yeah, we'll see. I can just about see a honing mark line, but it's not much. What I can see definitely is down the bottom of the bore. I can see where the ring gets to, and then never goes any further, and there is a definite lip, it feels like. So that could be a sign of an issue that it has worn. And obviously you get the thrust side as well that you need to measure, and the bore can go oval. So next is going to be measuring with a bore gauge. So like I said, I'm not doing a procedure of how to do things, but I just want to show you quickly what an engine builder told me to do. Is basically take the spec towards the bottom of the bore, because that's where it's worn the least. So put your bore gauge in, and basically what you're trying to do, and I can't really, let's spin you around a little bit, see, maybe, is you then zero the bore gauge at your least warm part, and then basically you want to check the center of the bore. So basically you're rocking it, and the closest you get to the zero mark is your tightest part. So this comes out about 1, 2, 3.5. So 3.5 marks is, and each mark is 0.01 millimeter. So the wear is 0.03.5 millimeters. And I was told, without looking more into it, I was told by an engine builder that basically if you're under 0.1, so we are by quite a lot, then you're fine. You take the bore gauge up a bit further, don't do it right on the lip where the rings don't go, just a little bit under it, and again you're looking for the closest zero. It's about 4, so again still okay. I then did the thrust side and the top 3.5, 4, even down to 2 at the bottom. So it's looking like this. I've only done one cylinder, but looks like cylinder 1 does not need reboring. So it will just need, you can feel the glaze on it, it will just need honing to get the hone marks and everything, get the glaze off, bash the glaze off, and then get the hone marks back in so the rings can seat when you put new rings in. So I've got all the pistons out, had a look at the big ends, and they look really good actually. I really don't think there's any issue on those journals. They look good. Not picking up anything with my nail, so that's good. Obviously got to hone it, so that creates lots of minute metal particles, so I will be taking the crank out and replacing the mains. Spinning it back over, I've checked all of the pistons and they're all within spec. Number 4 was the worst, and that was only maxing out at 0.04.5, so still within spec. So I went to Machine Mart and bought the Clark 3-legged glazer. There are cheaper ones out there, but this looked like a good bit of kit, so I went and got that one. This one's adjustable, very springy, so hold the legs together, get them into your bore. This adjusts the tension, so just doing it up, adjust the tension on the stones, and then on a slow speed, let's give it a go. Got WD-40 sprayed onto the bore. See what we're getting. Oh, that is doing really nicely. It's completely taken off the slight lip I had at the bottom where the piston rings don't get to, and at the top. Really good. So I'm going to try, my cross hatching is quite shallow, so I'm going to try and move up and down quicker to get the cross hatching to move out at a better angle. Yep, that's better. So the bores are all honed, look really good. So it's time to clean up the block. So basically I've cleaned up most of this already. Well, I've cleaned up the first part of it, but one of the best ways is a knife blade to get all the residue of the gasket off. Then I'm going to clean it all through, going to degrease it, because obviously when you're boring, you're actually grinding metal, and you don't want that to go into the oil ways and get into bearings in the future and stuff. So damn good clean all the way through. So completely degreased the block, went over it with degreasing and a toothbrush, tried to get in everywhere, get the rubbish off, went all over it. Then I've washed it through with a hose pipe to get all the degreasing and everything off. It's looking pretty good for a 15+ year old engine. Well, about 15 years, yeah. So yeah, obviously you don't want to leave water in the bores. I'm going to dry all that out, and then I'm going to put a light coating of oil on the bores so they don't rust while we're waiting for parts. So I've put the bottom shells in. The thrust washer goes in the middle, which obviously controls the thrust of the crank, which is something we need to measure in the future. Apologise for my voice, I'm suffering from man flu. So I've got the crank in, all cleaned up, new bearings, and then obviously I need to put the I want to measure the main bearings. So I'm going to use plastic gauge, which comes in little sheets like this, and inside here is a little green strip that you lay in your bearing on your mains. Put your bearing cap on, tighten it all up, take it off, and then obviously the little plastic gauge has squished down. And then what you do is you use this gauge to find out which best matches the plastic gauge size, and that gives you an indication of what clearance you have, and we'll have a look at that in a second. So I've been having some fun with the engine, trying to get the check the specs on the crank, on the mains. I plastic gauged it all, and these were just about in tolerance, but this one didn't seem to be. That indicated that maybe we had an issue here. So I then looked up the measurements for the bore without the bearing in, the bore of the main journal, and also the crank journal. So basically, I'm not going to go into all the details, but you can use a bore gauge to measure, obviously this isn't done up anymore, but to measure the bore. So I've used a bore gauge to measure the bore, transferred that to a micrometer, and I've checked that against the specs, and the bore is in spec, and also the crank journal is within spec. So that's all standard specs, so should take a standard bearing. So I'm quite happy with that. So I've double checked that, and the the sizes are correct, so it should be absolutely fine. I've replaced the center thrust washer, which obviously locates the crank from back to front, and hoping for a little bit of better reading. We had 0.33 before, so let's have a look. We're on 0, and then not a lot of difference, so we're getting 30.30, so we've made up, you know, 0.003. You know, at least we know that's pretty much the max we can gonna get. It is within tolerance, so that's what we're gonna go for, and it's nice to have new bearings throughout, so that's good. So now we've checked it all, we can put build lube on the bearings. Basically this will protect it on initial startup when the oil isn't there. So now we're going to place the crank in. There we go. And then you've got the caps, which on this engine are all together in this one big assembly. Knock that gently down into place, and then we'll start looking at bolts. Like I said, I'm not going to give loads of stats, I'm just doing the bolts. You've got to look up the torques and then the angles. I don't want to put anything on here and get it wrong, so I'm literally just showing you that we're rebuilding this engine rather than a how-to video. There's obviously bolt tightening sequences you need to follow, things like that. So look it up, you can find it on the web and go from there. So having a look at the pistons, in my eyes the skirt wear is very good. They've obviously got a coating on there and it's working. But yeah, to try and see some issues, so these are the original rings obviously. I've put feeler gauges in, and I've done the I've checked the gaps at the top compression rings, and they're fine. I can't get the so yeah, they're absolutely fine. So pistons are good, should be able to do new rings. So basically I've been soaking them in degreaser, and it looks like that's working because all the stuff's coming off. So I'm going to take all the piston rings out, give them a damn good scrub in between the rings and everything, make sure it's all the oil ways are clear, everything like that, and get them ready to I won't put new rings on yet. What I'll be doing is I'll be putting in bearings, and then checking the bearing, the big end gap. So that'll be my next job. So taking the first oil control ring off, which I've taken the lower one and I've taken the upper one, and it was very difficult to move, and that's what people talk about. They talk about this oil control ring getting stuck, and if you look on the, so that's the top surface of it, nice and clean. Look at this, it's just absolutely gunked with oil build-up, loads of it. And it's on the other ring as well, that's even worse. So another interesting thing I'd seen on another video was basically once you've got the oil control ring out of here, you've got the where the oil comes out, and basically these get clogged, and I just turned a drill in there. I don't know if you can see that, but that is fully clogged with oil remnants. So I'm guessing what happens, maybe, I'm not an engineer, is these holes get clogged up, it's not draining away, and then basically your oil control ring gets gummed up, and then that's the start of all your problems. So yeah, just cleaning out those oil drains. So as I've just been saying, I've cleared out these drains. These are obviously also drains as well, but the ones going horizontally in the piston, there's only one each side. I've seen people modifying them and they're putting 1, 2, 3. Again, I've spoken to an engine builder friend, and I'm not going to go overboard. I'm just going to put one per side, so 2 extras on the skirt sides or the pistons. So I've marked up my line. Put this on a slow setting. Bit of movement in the crown, but hopefully it's going to be all right. Try and keep your drill vertical. Obviously you're going into aluminium, so it's not that hard. And that is an extra drain hole, so just going to put 2 on every single piston. And on the back, that's where it comes out. All I do is I'll just clean that up with a deburring bit, but that should be absolutely fine. So I've got a bit of plastic gauge in there. It's a new set of plastic gauge, so it looks a little bit different. And then I'm going to put the cap on. These are fractured rods. It means they're actually broken. They were one piece and they're broken, so they only fit onto the exact rod. So I marked them before I took them off. Get my old bolts. So I'm going to torque those up, take the cap off, and then see what the plastic gauge says and measure it. So this is the first time using this plastic gauge. It looks a little bit strange, so I'll make sure I'm getting repeatable things on the other ones. So this is your plastic gauge. You get your dart, you get your gauge, and the one I got it for closest, it may be, yeah, closest is 0.038, and the scale was something like 0.025 to 0.052, so we're within that. So this one's absolutely fine. I'm going to check and make sure that the plastic gauge always comes out like this on all the other 3, and make sure they're all in good order. And then it will be putting piston rings on, putting the pistons in, and then putting the bearings on the bottom end, and then that's very much, you know, your main bit of the bottom end done. So we're going to have a look at ring gaps. So basically you get your new piston ring. These are genuine Mazda piston rings. You place it into your bore. You then use the piston top to centralize it. We're then measuring the gap, measuring that gap between the 2 ends there. So the specifications I have are standard is 0.16 to 0.31. It's tight. I can't push it all the way in. So I'd say I'm just about in spec on that for standard clearances. So that's good. So I've got the piston. Starting to look at piston rings. This is a piston ring tool, really cheap. Just helps you expand piston rings to get them in. I've then got this diagram. So you don't normally want your piston, the gaps in your rings on the thrust sides. So this is indicating with the pin that way that my upper oil rail was going to be like the 30 degrees, lower oil rail is going to be off to 30 degrees. The top ring is going to have the gap there, and the second ring is going to have the gap over here. So this is important to note when you're putting piston rings in. So yeah, let's get going and see how it goes. So this is my top ring, which is a completely rectangle ring. There's no scrapers on it or anything like this. So it's saying my top ring needs to be over there. So I will try and do this awkwardly across like this. That is my top ring in. You can see our brand new rings have a lot of spring in them, way more than we had before. So you want the gap. You might even mark it on the piston. You can always do that to help yourself. So we're wanting top, second, and then oil top, oil lower. So that's how we're wanting them. Right, okay, so so that's all marked. So that's your first ring set, second ring set, and this is one where you need to be a little bit careful because your ring has a scraper, so it's not uniform all the way around. You can see this indent here. That needs to be on the bottom facing out, and then this one is going to be, the gap's going to be this side. So again, make sure your scraper's at the bottom, which it is. Don't put it in your oil way, which is what I just did. Oil control ring section. This could be really fiddly, especially trying to keep them roughly in the right order. So that's like that. So that's the second ring. And then we're looking at the oil control rings. We've obviously got two thin rings either side of the waffly part. So we want one of the rings at the bottom. So still working on the oil control ring. You then have the oil scraper. So this is, they're calling it the spacer, and they want where do they want the edge of that? Oil spacer ring and second ring, so they want it over here. So I was putting the oil control ring in incorrectly, so you need to put the waffle piece in first, and then the upper and lower control rings of the waffle go in afterwards, and they sit into it. So that's what I was doing incorrectly. So I've got to line them all up, but that is all your new rings in. You can see the elasticity in those. So then you have to use a ring compressor to get them all lined up, compress it, and then tap it into your bore. So that's what I'll be doing. Okay, we're looking at putting in piston number 1. I've got all the piston rings done. I've got the piston ring compressor around it. This can be a pretty tricky thing because the piston, when you get to here, the piston rings like to pop out at the bottom of the piston ring compressor, so that's always fun. Right, let's have a look here. So make sure you've got an arrow on your piston, arrow there, it's pointing forwards. Drop your piston in. And then you've got your piston ring compressor as tight as you can do, and you're just trying to keep pressure down on the compressor. And it worked. Went in first time. Look at that. Some of the times I actually talk sense. So you've got your arrow there pointing that way. That's your piston in. Obviously it's now stiff because you've got your piston rings nicely in there. So we're looking at the first piston. There's probably a better way of doing this, but I don't quite know it. So I want to get the bearing into the piston. Maybe I should have put that in beforehand. There we go. So I know which way my cap goes round. So I've got a mark on it. It feels good. We've got new bolts going in. 19.2 pounds-foot to 23.6 pounds-foot, and then 80 to 100 degrees. I've got this set to 20. Let's just knit them up a bit equally. There we go. That's 20. Then you've got to get your angle gauge. So it's the bottom bit you need to hold. So let's see how far we get. .95, that'll do. And we're going to do the other one. Okay. Try and hold everything at once. There you go. So that is one completed piston, and luckily it seems to be turning. That's always good. So now we're going to start working on the head. As you can see, I've already got the cans out. That was done when we were taking the engine apart because we couldn't get to the head bolts without taking the caps off. So just to let you know, on this engine they're all marked. So E4 exhaust 4, this one's intake 5. So don't need to worry about mixing them up because they are already marked on the caps, so that is good. So basically we don't particularly perceive there's any real issue with the head, but I want to change the stem seals, valve stem seals, and then probably, well, I will get the valves out. I'll clean all this up. Obviously this is where it's been burning oil, you can see it on the valves. Get them all lapped in, get the face all cleared up, and get that ready to go back on our fresh bottom end. So yeah, from what I was looking at before, there was no signs of blowing or whatever, but it's obviously quite an old gasket, so yeah, looking good. So I've been cleaning up the valves. Going to try and get the caked on stuff on the exhaust off when the valves are out, but I've pretty much cleaned up the inlets, all fine. So what I want to do is get the valves out. Obviously these are the valve springs, valve spring retainer, and then you've got two little collets. So basically you have to push down the retainer against the spring, releasing the 2 collets, which you can take out, and then everything comes apart. I've got a trusty valve tool, but obviously this bit goes onto the valve and this bit goes there, and suddenly you think, well, that's not going to work. So I've hastily modified this socket that was for a wheel socket, and it may be, hopefully it's wide enough to get the collets out. I might have to make that a bit wider actually, now I'm thinking about it. One collet has come out, but that's not the way to do it. I don't seem to think this is too tall. Oh, it's given. So that's not the way to do it. I haven't got enough leverage on this. This is too long. The collet is still stuck in the top there, so there's these little, there's the other one, the one's there. Here's your 2 little collets, if you can see that, probably can't. Then your valve spring, it's like a beehive, that's why they call it a beehive valve spring. So basically this is your valve, and you've got your valve stem seal just down there, and obviously the valve moves up and down within that. There's your valve. Going to measure the thicknesses of the valve to make sure they're okay. Pop those stem seal off, clean all this up and replace all the stem seals. So I started to take the valves out. They're all over here, so obviously exhaust ones are quite sooted up. So yeah, so got these ones out, been taking the this valve stem seals out. So I just find the best, well, maybe the best, if you've got the proper tool then great, but if not, grab them, go as hard as you can, turn them to break the seal, and then pull off, and they normally come off. So lots more to do here. Then obviously got to make sure this is all cleaned up, and valve stem seals, and then obviously lap the valves in. But so far I'm not looking forward to putting the collets back in. They are a bit fiddly, but it is coming apart, so that is good. So I'm going through looking at the valves. This is an exhaust valve, and I'm just measuring the stem thickness to see whether they're still in spec. So on an exhaust valve, in millimeters, it's saying it's 5.465 to 5.48. So measure it at different points. That's all right. We ran out of charge on the camera there, so just doing another one. That's coming out just under 4.7. Same again, just over. So when looking at this, there is obviously some wear on there. It's not at the bigger end, which is 5.48. we're definitely down at the minimum side of it, but it's still within the standard spec. So I'm going to go through all of those. I have checked all the intakes and they're fine, so I'm just going to finish off doing the exhaust. So I'm looking at lapping in the valves. I've done one. So what I want to show you is, I hope you can see, so when you're looking at the valve seat, normally when it's not lapped in, you can see little blotches maybe, it's not uniform. It's quite hard to see. Let's see if I can shine a light on there. You can definitely see some blotching on that one. And obviously the piston, sorry, the valve is very dark, that type of thing. Anyway, so there isn't really, I can't, on the first two I can't really see any major issues of just lapping them in. So on the seat I've ground this one, and you can see that it's a uniform kind of dulled sanded colour. And I had a little bit of speckling over here that I just kept lapping in until I got rid of it, so that's now uniform. And then the valve has the same thing, has that dull edge all the way around. If you find you got spots where it's not dulled, it just means it hasn't got to that yet, and you need to keep going until you have a uniform ground area. So keep going through on those. So that's one lapped in. And then what we do is, it's quite simple. I think you can get this at Halfords. I've got fine and coarse grinding paste. I have just used the fine. Don't need too much, just need to put it on the lip that you want to grind. Obviously it's going to get spread round. Pop that into the valve seat, and then this one, you can see it's been used a little bit, is literally little suckers that go on the end, and then if you've got good enough suction, grinding, keep moving it round. I won't go too much because we'll be able to see what we can show you what's going on. So let's wipe off that seat and have a look. So looking at it now, I would say it's not uniform. You probably won't be able to see it, but in the middle of that seat, it's still black. Working around, yeah, it's definitely not seated yet. There's black bits over here, so you really just need to keep grinding softly until you get it all ground in, and then you've got 16 to do. Awesome. As you can imagine, it's taken quite a long time to clean up the exhaust valves. They start off really quite gunked up all over the bottom of them, all on the stems. So yeah, working to clean them all up to look like this one takes quite a while, but I think it's worth it. So once I've cleaned them all up, I'll then lap these in. I've lapped all the intake ones in and they went fine, so it's just working on these. So now we're going to look at putting new valve stem seals in. I have cleaned it for as much as I can, so it should be fine. Obviously got all the old valve stem seals out, so the new ones, a nice new packet of them. So the best thing to do is get the valve stem seal, get a socket that fits nicely, goes onto the base, and then push them on. Was it that easy? Yes, it was. That's scarily easy, wasn't it? Just making sure they're getting all the way home. Yep, I can feel it is an interference fit. So just keep going along. 16 of them to do. Yeah, it's not hard. I am in no way a valve expert, but basically you put your valve in from the bottom, you've then got your spring and retainer, and then there's a groove in the top of the valve, and what you're trying to do is get the two half collets into that groove and then release it, and they hold it all together. Getting these in is an absolute nightmare. If you have a better valve compression tool, then it gives you more access. I am trying to get through that hole there, and it's really hard to even see, so I'm using my phone light. And then what I'm doing is I'm putting grease on the inside of these collets, putting them on the end of a screwdriver, getting another device, push them into the groove, the grease holds them stick, push them around a bit, then stick the next one in and release. Sounds really easy, it's been a nightmare. So that's my life at the moment. Once your collets, if you can even see in there, let's see if I can shine some light. Got your collets, there we go, there's 2 collets, got the grease holding them in. And then in theory, if nothing goes wrong, release the compressor and your collets are in there, holding your spring in. I always give it a little bit of a test, so I push each side of the collet and then push the valve down just to make sure it's all working. And that is another one done, 2 to go. So I'm going to need to put up with some slightly different camera work today, sorry, forgot my GoPro. So ready to put the head on, put the gasket on. It says in the manual to put some grease, it's not grease, sorry, some silicone sealant, this type of stuff, and these 2 front notches. Then I'm going to place the head on. Then I'm going to put the bolts in. It says to, it says in the Haynes manual to lightly oil the bolts, not too much though, but lightly oil the bolts. It doesn't actually say that in the other manual I found online, but I have oiled bolts before, so I'm going to go with that. Not too much on there though. And then I'm going to go through the tightening sequence. There's 4 stages to it. Again, please look it up. It does use an angle gauge, so you're going to need that. But I'm going to go through those stages, get this head on, and get this thing moving forward. I've got the head bolts all torqued up, got the head on the block. Happy, all went together absolutely fine. Now looking to put the camshafts in. Again, I'm going to put some assembly lube on all the faces here as I put it in. Just helps when you first start. So there's lubricant there. Cleaned up the cams, they look alright. So yeah, lube it up. I'm going to put all my cams back in, do it all up in sequence and torques to specified. So now we need to get the engine in top dead center and the timing correct before we put the timing chain on and the cams in. So on the front here, there's a little bolt, bear with me, there's a little bolt you take out and you have a timing kit. I've got a US Pro tool one or whatever. So this goes in, so that screws in, and the crankshaft there, come on, zoom in, crankshaft there butts up against it. So there you go, that's top dead center. You double check, piston is at the top of its bore. Then what you've got is this bar at the back to go in the slots on the camshafts. Note the way to get the camshafts around the right way is this bar, this slice inside the camshaft is offset. It's not in the center of the camshaft, it's offset to the top, and it's you want that slice towards the top is where this bar slides in. So this is the oil pump. I've cleaned it up. It doesn't have a gasket in a Mazda here, just goes onto the dowels, done up. I'm told that the Ford has a metal gasket, but the Mazda doesn't. So I've just cleaned both surfaces, and yeah, that should be fine. So this is a new timing chain kit. So this is a whole kit. There's 2 chains. There's obviously the main chain and the oil pump chain. You get a new oil pump sprocket. You get all the little tensioners. You get the double sprocket that goes on the crank. Tensioner bits. A new, that must be the top sprocket, one of the top sprockets. Why'd you get one? No, work that out in a minute. And then a new tensioner in there. So yeah, it's time to get the timing kit done. So we've got a new bottom sprocket, which takes both chains and either side. This is the old one, and it's got diamond washers either side of it. That's all that holds the timing in place, so really important that you buy new ones. So 2 new diamond washers, make sure all the surfaces are clean, and then this with a washer each side is going on the crank like that. And then you've got the chain that runs the oil pump, which is the back small chain that goes on, and then obviously this is for the main chain. Looking to do the camshaft sprockets. I've got 1 new one in the kit, I'm guessing because it's for VVT and therefore you wouldn't need 2. I'm just going to replace one of them. Should be fine. These also have diamond washers, so you need 2 diamond washers for your cam sprockets, and you'll also need 2 new bolts for your cam sprockets as well. So those are things to do. Going to get those cam sprockets on. So most of the front end timing is now done. Just going to give you a quick recap. So obviously we're putting the sprocket on down here before. Don't put this sprocket on the oil pump. Put that sprocket and that sprocket on at the same time, pushing the chain over, and then do that one up. You then just slot this guide onto this pin here, so that's fine. These are they're loose, so you just leave these loose. You install this guide, obviously that one from earlier, and then once it's in this loose configuration, you then pull the pin. I showed you the right thing. This is the tensioner with the spring loaded tensioner, so you pull the spring out, this tensioner shoots out, puts tension on here, and this is when you then got tension on everything. You're going to hold the camshafts with the sprocket bit here, and you're going to hold that, and then you're going to do these up to the torque that you want. And obviously as you do them up, you're moving them in a tightening, you're tightening the chain that way. So yeah, that's all it's going to be. So I just got those 2 to do, and the timing is all done on the front. Working on the oil pan. So these don't have a gasket, they just have goo. Again, I'm going to be using this. And so basically you need to clean it all off, because once you compress it, it just squeezes inside the engine inside. So you need to get all that off, clean it all up, get ready for the new sticker you're going to put on. I'm going to take this tray off as well, make sure this is all cleaned out nicely, there's nothing horrible in the bottom. While we're here, get that all cleaned up, get that back on the engine, and then I can do the rear seal, because it seals. Not only does it bolt to the engine, but as you can see, it seals to the back of the pan. So I want that on first, and then I've got a nice new seal to go on. So I've cleaned out the pan as best I can. One thing you need to be careful of, obviously getting all this silicone off, but there is a groove here that's full of silicone. You need to clear out all the old stuff there, get rid of that. I've cleaned up the baffle plate as well, bottle that back together, and I think it's time to get that on the engine. So I've used RTV sealant on the pan. These aren't done up fully yet, but what you've got to make sure of is this mating face. Get a square edge or something like that. You want to make sure that the pan and the engine block are flush, so when this front cover goes on, it doesn't leak. Doing the rear main oil seal, it's going to be tricky on the engine stand, but I got the other one off. So this has got goo all the way along on the sump pan, which is where this bottom of the seal mounts. If you buy a Mazda one, I believe you don't get the centralizing tool, but this is Elon, is it? It comes with the centralizing tool that helps you centralize the seal onto the end of the crankshaft. So I'm going to do this. You basically trying to do this. So I've done all the sump up, and then this is obviously starting to dry, and you need to get this on before this sets. I've got the rear seal in. It's all gone quite well. I couldn't get the seal in with the arms in the way, so I had to do something a little bit dodgy, which was tie a cable to the rafter, take that one out, slide it in, and then carefully push it. Sorry, the camera looks awful. Push it over here with the tool that makes it line up, and then bit by bit there's a sequence to do your bolts up, and then you hope that that is all nicely gummed up enough. So that is the core of the engine done, all the timing done, the sumps on, the rear seals on, there's a new seal in the front cover. Front cover's all good and all torqued up. So yeah, you know, accessories like the water pump and other bits and bobs. I've put the intake back on with a new gasket, so that's on. So yeah, really good. That is pretty much the core of the engine sorted. Completely forgot to film this bit. That was my last video. So basically, get the front pulley on. This is the last bit that gets everything tight for the timing, and also you have to get this in the right position with these for, I believe it's the crank sensor that bolts onto here. So the easiest way to do it is you've got a 6mm bolt that lines up the hole in the pulley with the hole, the threaded part in the cover. So line that up. That means it's in the right position with the crankshaft pushed up to the stop and your plate holding the camshaft. So that's all the timing in the right thing. You can then get one of these tools on eBay. They're not very much money. So basically hooks inside the pulley. Someone on the other end will basically is just holding this still. They're not pushing on it, they're just holding it still when you do the bolt up. So then when you come to do the bolt, someone's holding that, you do that up. It's in 2 stages. There's a torque setting, then there's a angle gauge setting, and then basically once you've done all that up, then all the timing is in spec. That was a new bolt that went in. Then what you do is you take out the bolt in the side of the block, put the plug back in, take the straight bit off the cams, take this bolt out, and then that is all the timing done and basically the rebuild finished. So yeah, all done, sorted. Right, Andy's with me today. So you see me basically rebuild the whole engine. We've now got to swap it out. So I don't know the procedure, just going to basically show us getting stuck in. Got to get this one out, get the new one in. We've got a weekend to do it or we're going to lose the shop, like all the shows say. Yeah, we've just got to crack on, haven't we, Andy, basically?
Yeah, indeed.
Yeah, wicked. You're gonna
dirty.
Yeah, next time you see it, it will be in bits. So we're working on, basically cleared out this whole area. We're going to try and take the engine out from the top. Got most of the electronics all just put on top of the engine, because it goes down to the alternation stuff, we can't really get to it, so I'm hoping it's going to be easier to take it out with all the wiring on top. We've taken out all the gearbox bolts. We're just having a look at the manifold to see whether the engine can come out with the manifold on. We're going to find out. And then we've got the 2 engine mounts, and then we're going to be taking this out with an engine crane, taking all the ancillaries off it, putting those on the new one, slapping it back in, and then having a well-earned pizza and beer. That's what I'm looking forward to. So this is the end of 2 days of hard graft. Myself and Andy working, I don't know, 9 hours yesterday.
Something like that.
Something like that. Something a little bit shorter today, but we've got a nice new shiny manifold. You're going to want to see that, aren't you? So let's have a look. Nice new shiny manifold there. So we've got that on. Nice little added extra. We've got the engine in, all the ancillaries, gearbox and everything. It's all back together. I've just turned it over with the spark plugs detached to build oil pressure throughout the engine. We've got the FL22 coolant that's ready to go in. I poured loads in there, it sucked loads in, and we're literally about to turn it on for the first time. Let's do it.
Yeah.
We might have to wait for the fuel to build a little bit, but I might have done that on the turnover. Go for it. That's the noise we wanted.
Beautiful.
Yeah. Wicked. Well, there you go. It didn't. Valves and pistons did not meet, which is always fantastic. Yeah, we're going to now have to burp the system, get it to take in all the coolant. What we normally do is turn the fans on high on hottest setting, and it will be cold, and then as soon as it's got through into the heater matrix and the thermostat's open, it will start blowing hot, and then it will suck some water in and then close off the system, and then we're all good. So fingers crossed it stays like this. So we've got the new manifold on, and it does sound distinctive. Sounds good. There's still going to be some residual oil and things in the exhaust from when it was churning out oil before. I think in about a 3-hour journey, Andy was using about a litre of oil, so there was a lot coming through these. So that's probably all going to get burnt off, and then we can have a real see what we've done. But obviously there should be no issue now. So really chuffed with that. 2 days of hard graft, and it's working well.